All right, in the last bit here on 12.0 for the review of polynomials, we're going to go ahead and talk about factoring polynomials. Okay, now I've included in question 4 lots and lots of different examples just to illustrate lots of different kinds of things that can happen when factoring. And so I'll break this up into a couple short videos. Now, given that this is review material, I really encourage you to do as many of these that you can before watching the video, and then use these videos really as just a way to check your answer and to fill in any gaps. Okay, so let's start with part A. We have x squared plus 6x plus 8. Okay, and as a little warm up here, in part just to emphasize the pattern that we saw in question 3 with multiplying. Let's say I have two binomials, like say x plus 3 times x plus 4. Okay, so if I multiply these out, I'm going to get an x squared plus 4x plus 3x plus 12. And then I, of course, can combine those middle terms, and that's going to give me a x squared plus 7x plus 12. Okay, the big takeaway here is that the 12, we're building that from the 3 and the 4, right? It's 3 times 4 that's really giving us that 12. How about the 7x? Where's that coming from? Well, for that, right, we were doing 4x and 3x, right? You see it right there when combining. So put another way, it's really just the sum of these two numbers that's producing the 7. And then lastly, how are we getting this x squared? Well, that of course is just coming from the x times itself. Okay, so now what we want to do with this in mind is just reverse this process, right? Factoring is just the inverse process from multiplying. And so I'm going to go ahead here and set up two binomials. Now to build my x squared, I'm going to need an x and an x. To build the 8, well, for that I need two numbers that are going to multiply to give me 8. I'll call it, say, box and triangle, right? So what are two numbers that multiply to 8? Well, there's 1 and 8. There's also 2 and 4. Now, what about the 6? As we saw below, right, this is going to have to be the sum of these two numbers. They're going to have to add up to 6. Okay, so of these two possibilities, it's going to be the 2 and the 4 that are going to do the job, because 2 plus 4 is 6. So here, I'm going to go ahead and say x plus 2 and x plus 4, and that's going to do it. Okay, now with this problem, or really any other factoring problem for that matter, you can always easily check your answer by just multiplying this back out. X times x is x squared, 4x plus 2x is 6x, and 2 times 4 is 8. So it's doing the job. Okay, great. Moving on to B, notice here this is a binomial, and there is a common factor of x. So for that reason, I'm going to go ahead and just factor that x out, and I'm going to be left with just an x minus a 3, and really that's as far as I can go. So we're done there. Notice there was not a common factor across all three terms in part A, so we weren't able to do this kind of thing back up in part A. Okay, moving on to C. Now here, notice there is a negative for our leading coefficient. And if that's the case, it's a good idea to always factor it out. Okay, so I'm going to go ahead and factor out that negative. There's also a common factor of x, so I'll factor that out as well. And that's going to leave us with an x minus a 3. When you factor out a negative, you are going to change the sign of each term. Okay, keep that in mind. D, well, there's now a common factor of x and 4, so I can factor this as 4x, and then I'm going to get an x plus a 3 left over in parentheses. That's going to do that for D. Now for E, we have a leading negative again, so I'll go ahead and factor that out. And I'm also looking at a common factor of 4, and an x, so factor those out as well. Now we'll be left with an x minus a 3. All right. For f, well, there's no longer a common factor across, right? There's no x in the 15. And we're looking at a trinomial, so we're now really back in the territory of part A. So we're going to look at building a product of two binomials that will multiply out to my original trinomial. So I'm going to need my x and my x to build my x squared. To build a 15, well, again, I need two numbers that will multiply to 15. And for that, well, there's fortunately not a lot of possibilities. 1 and 15 or 3 and 5. Okay. One other thing to notice here is that this middle term is negative. Okay. So because of that, right, both of these numbers, whether it's the 1 and 15 or the 3 and the 5, whatever I'm going to put into my binomials, they're both going to have to be negative. Because if you give it some thought, there's no way I could come out with a negative middle term if these two things were both positive. Okay. Now, how can I build a negative 16 where I'm thinking, hey, I can make both of these negative? It's going to come from the 1 and the 15 combination, because now I'm looking at minus 1 minus 15 is a minus 16, and that's how we're going to get that middle term. And so here we're looking at x minus 1 and x minus 15, and that's going to do it. And again, we can just easily check our answer by multiplying. X squared minus 15x minus 1x, that's a minus 16x, and then plus 15 to finish. All right, on to G. Well, watch out for that lead negative there. I'm going to go ahead and factor that out to start. And that's going to leave us with x squared plus 7x minus 18. Okay, and now let's go ahead and play that same game with our trinomial inside the parentheses, where I'm just going to leave that negative I factored out from the very beginning just out in front. So I'm going to need an x and an x to build my x squared. Then I'm going to need to build a minus 18, right? And for that, I need two numbers that multiply to negative 18. So notice here, since their product is negative, the signs of the two numbers I'm going to put in the binomials now have to have opposite signs, right? They have to be opposites. So what are my possibilities here? Well, I could do 1 and 18. I could do 2 and 9. I could do 3 and 6. Okay, but I know one has to be positive and one has to be negative if they're going to multiply out to be negative 18. And the other thing to keep in mind, of course, is the fact that the middle term there is a positive 7. So going down this list, I can build a positive 7 from this middle combination by making the 2 a negative and the 9 a positive. Those combine to a positive 7. And so there, I'm given the factorization x minus 2 and x plus 9. And again, that negative I factored out from the very beginning is just hanging out in front. Okay, I'm going to go ahead and stop there. We're going to look at the next batch of problems in the next video.